The Cascade Mountain Range, majestic, rugged peaks towering into the sky. The Columbia River, powerful, unending water flowing to the sea. The Cascades dominate America's Pacific Northwest, stretching from Northern California to Canada. Slicing across two northwestern states, the mighty Columbia River forms the border between much of Washington and Oregon. These two magnificent creations intersect at a spectacular place called the Columbia River Gorge. It is a place where the unstoppable waters of the Columbia carved a path through the immovable mountains of the Cascades. The Columbia River Gorge is 75 miles of artwork. 3 miles wide, it extends from the Sandy River east of Portland to the dry plateaus along the Deschutes River. It's home to a mixture of climates and ecosystems. Where a traveler can find dozens of cascading waterfalls and over 1,000 plant species. The Columbia River Gorge breaches a wall of mountains that holds back rain-filled clouds coming off the Pacific Ocean. West of the gorge in Portland, about 42 inches of rain falls annually. Midway, Hood River receives 29 inches, and at the eastern end, rainfall at the Dells drops to 14 inches per year. Blocked weather systems funnel through the gorge, making it a place of severe winds and weather, but it's also a place of breathtaking beauty. "200 years ago, when Lewis and Clark first explored the new territory, river travel was the only way to access this hidden paradise. By 1882, burgeoning timber and fishing industries made necessary the construction of a railroad line along the river. The early 1900s brought the dawn of the automobile age to America, and people seriously considered building a road through the gorge. Steep terrain bounded by cliffs on one side and the Columbia River on the other posed a formidable obstacle. But a wealthy industrialist named Samuel Hill had a vision of opening the Columbia River Gorge. He and other prominent citizens, such as lumber magnate Simon Benson and businessman Julius Meyer, dreamt of making it accessible to tourists and vacationers from across the country. Sam Hill knew how to sell his vision. Don't stop talking about it. Tell anyone who would listen. He gathered support among the Oregon state legislators with his convincing arguments. "We'll cash in, year after year," he said, "on our crop of scenic beauty without depleting it in any way." Hill invited Samuel Lancaster, a noted civil engineer, to help him realize his vision. They toured the roads of Europe, like the Oxenstrasse on Lake Lucerne in Switzerland. Lancaster practiced building them on Hill's Mary Hill estate on the Washington side of the gorge. Experimenting with materials and equipment, he designed and built what is known today as the Mary Hill Loops, the first paved road in the state of Washington. His goal was to make the Columbia River Highway a masterpiece. After locating the best vistas and beauty points in the gorge, Lancaster designed the highway to provide access to these areas. He also conformed the road to fit the gorge's natural terrain, blending the highway with its stunning surroundings. The highway met and often surpassed the highest engineering standards of the time. It was a paved road 18 feet wide with 3-foot gravel shoulders, a maximum grade of only 5% negotiated steep climbs using curves with a minimum radius of 200 feet. Construction began in 1913 and was completed to Multnomah Falls in 1915. It was the first major paved highway in the Northwest. Work on the highway continued along the Columbia River, both west to Astoria and east to the Dalles. By 1919, all but a section between Hood River and Mosier were finished, where a promontory towered 800 feet above the river. With sheer cliffs on one side and a railroad on the other, Oregon State highway engineers had no alternative but to design a pair of tunnels through the basalt. A basalt rock 1 foot around weighs about 200 pounds. It is extremely dense material. Crews broke up the solid rock with dynamite, but carved out the tunnels with picks and shovels. The loose material was mucked out by horse-drawn wagons. Boring a pair of tunnels 493 feet long was completed in just over 1 year and cost $20,000. The Mosier Twin Tunnels united Oregon. People could drive from the Dalles to the coast in 1 day on over 160 miles of paved highway. Their journey through the gorge crossed 27 bridges, 8 viaducts, 4 tunnels, and 3 sets of loops.
The historic Columbia River Highway, when completed in the Columbia River Gorge, really set Portland and the state of Oregon on the map. A magnificent highway, now considered the first scenic highway in America. It established a precedent of how a highway could be both a marvel of engineering in a very difficult environment, and also could be just absolutely beautiful and aesthetically very pleasing. It was somewhat elitist in that it was sort of restricted to those people who had their first automobiles, but the automobile became popular very quickly, and Henry Ford and others mass-produced them, and so the highway became, if anything, very, very crowded in just a few years after it opened, and was loved too much.
The highway opened the gorge to motorists, to those who wanted to enjoy the splendor of this natural treasure, and to those who wanted access to markets previously blocked by the mountains.
The highway, as designed by Lancaster, was very, very satisfactory. It was 18 feet wide, and it had a maximum grade of 5%. It made it very, very convenient for the vehicles of the day, where if you were going 45, 50 miles an hour on a straight stretch, you were scorching, as they used to call it. And the average vehicle speed on the highway was probably around 35 miles an hour on a good piece of road, and the highway took that very, very nicely.
In less than 10 years, however, it wasn't good enough. Vehicles became faster, bigger trucks carried heavier loads. The highway's popularity made it too inefficient. Given a taste of what could be, the public wanted more. By 1931, there was general agreement that a water-level freeway with fewer curves was necessary. Beauty and elegance would be traded for speed and capacity.
As the trucks got bigger and bigger, it was difficult for them to navigate. Cars were bigger and they were moving faster. And if you got a slow truck, I do remember driving behind slow trucks, and you just dawdle along, and there'd be one place in 1,000 where you could get by. So it was obvious that something had to be done.
In 1936, construction began on a freeway along the river, bypassing much of the old highway. While several segments continued to carry traffic, others were abandoned, and without maintenance, the highway structures deteriorated. Over time, portions of Hill's and Lancaster's gift to Oregon had become an unsafe eyesore. The tunnels in particular faced a precarious future. Built to bypass narrow, unstable areas along the gorge, safety was an issue as soon as they were opened. Rockfalls in and around the Mosier Twin Tunnels occurred frequently. Masonry portals were necessary to hold unstable rock in place at the tunnel entrances. Accidents occurred in the twin tunnels as two-way traffic shared the narrow road. They were later widened and eventually restricted to one-way traffic. This required cars to stop under a cliff where rock falls were prevalent. Occasionally, travelers waiting to pass through were trapped by rock falls. The west end was especially dangerous, lying 200 feet below cliffs of loose basalt. Bypassed by the newly opened freeway along the river, the Mosier Twin Tunnels were closed in 1953. Unstable rock remained a safety hazard. Also, there was real concern that the tunnels would collapse and spill rock onto the railroad main line lying below. To prevent such a failure, the state highway engineer decided to fill the tunnels. The last piece of the historic Columbia River Highway, put in place 34 years earlier, was closed for good. Or so it was thought.
In 1981, the Historic Preservation League of Oregon and others throughout the state had an interest in restoring and preserving the historic Columbia River Highway, both the segments that are drivable and the segments that were abandoned. The abandoned segments were actually pretty bad, some abandoned since the 1930s, most of them since the 1950s. Masonry walls had fallen into disrepair, and some segments had actually fallen over the cliffside down into some rock slides. Guardrails were rotting away, the wooden guardrails. Moss had grown over the roadway itself. Trees had grown up through the asphalt, and they were pretty much just melting back into the landscape. Those who mobilized to try to save this highway in the 1980s and, saw it as an important example of our engineering past. Many here in Oregon really had the understanding that this road had at least local and regional significance, if not national significance, for its contribution to American culture.
In 1986, Congress passed the Columbia River Gorge National Scenic Area Act and directed the Oregon Department of Transportation to develop a plan to restore the historic highway. The Friends of the Columbia Gorge and the Historic Preservation League of Oregon wanted to assure that this plan did not sit on the shelf. They successfully lobbied the Oregon legislature to declare that it is the public policy of the state of Oregon to preserve and restore the continuity and historic integrity of the remaining segments of the historic Columbia River Highway for public use and enjoyment. ODOT began the extensive restoration process, repairing stone walls, guardrails, overlooks, and bridges along the historic highway. Abandoned portions were made into biking and hiking trails, such as this segment from the Bonneville Dam to Cascade Locks. Reopening the Mosier Twin Tunnels became a priority in the restoration effort. As in 1919, it would re-establish a link along the historic highway between Hood River and Mosier, allowing people to enjoy breathtaking vistas from high above the river. Crews began work to open the tunnels in May of 1995. Reopening them, however, posed a unique challenge to ODOT engineers.
Tunnels need to have a rock all the way around them, and so that the hole in the rock is basically supported by arching that goes around. And if there's more rock on one side than the other side, then there's unequal loads, and the rock fractures and falls apart. From the photos, we saw that there was a lot of columnar basalt, which has a lot of joints in it and breaks up quite a bit. So there was a real possibility of not having, or maybe even losing, the tunnels. So we had to go ahead and proceed very slowly. So we set up the excavation so we'd only take a little bit of material out, actually go in and shotcrete the top of the tunnel, and then put in rock bolts and basically support the top of the tunnel a little bit at a time. 30 feet at a time is the maximum we'll let the contractor go and work in that.
Rock bolts are 1-inch steel rods averaging 15 feet in length. Holes are drilled into the rock, and the rods are inserted and tightened down, putting the rock in compression and the rod in tension. Then the voids around the steel rods are filled with grout. Hundreds of rock bolts cover the roof of the tunnel, locking the loose rock in place and giving structural stability to the arch. Before and after rock bolting, 4 to 6 inches of fiber-reinforced shotcrete is applied to the tunnel roofs. Laced with thousands of steel strands, the shotcrete works with the rock bolts to shore up the tunnel interior.
The east tunnel, which was the longest one, took about 6 months from the time we started, and it was a learning process to try and start slow and work through and remove the material and get the tunnel stabilized. We had a lot of trouble in the smaller tunnel, and from the aerial photography we could see that before we even started work that you could see a hole up above on the east end, and so we knew that part of that roof had collapsed. And there's very little material over that tunnel. So during construction, we had that part of the material collapse down on the east end of the west tunnel, and then we had a lot of problems with the west portal of the west tunnel. The tunnel actually collapsed and came in on us. And so when it collapsed, you could see all of the bars down, and so some of the bars held, and we were able to go ahead and form it up from the bottom, and basically we filled that in with concrete at the west portal of the west tunnel. The tunnels were actually the easier part of this project. The most challenging part of this job was really the rock catchment structure, to try and design something for this 700 feet west of the west tunnel to be able to adequately get people through there safely. Basically, a rock, no matter what the mass is or what the weight is, on Earth it's going to get to you falling 200 feet in about 3.5 seconds. And a 5,000-pound rock falling 200 feet is basically 1,000,000 foot-pounds. It's just the weight times the height of kinetic energy. So we had to build a catchment structure that would absorb the energy.
The catchment was attached to the cliff itself, maximizing stability and strength. Using the same technique as in the tunnels, 25-foot anchor bolts were drilled into the wall of the cliff, forming the base of the corbel shelves that would hold the catchment cover along the rock walls. Rocks are likely to fall anywhere on the structure, so every part was designed to survive such an impact. The columns, for example, are heavy-duty and filled with reinforcing bar. Spaced close together, they will support the cover as falling rocks assault it year after year. An innovative technique uses cellular concrete to protect the structure by catching the rocks. 6 feet of cellular foam concrete was poured over the lid. It acts like styrofoam, absorbing energy from an impact and dissipating that energy before it reaches the rigid concrete beneath it.
The catchment structure was built actually very high, so as you approach the tunnels you would be able to see the beautiful portal structures that were built out of the ashlar stone that was the original construction.
The idea here, as well as along the entire highway, was to allow visitors to appreciate the engineering achievements of almost a century ago.
The historic Columbia River Highway restoration has been a dream since 1981 when the National Park Service did the first study. We've been actively working on this project since 1987, and it is with great pleasure that we see another large section of the historic Columbia River Highway State Trail open to the public. The goal set in front of the Historic Columbia River Highway Advisory Committee was to preserve and reconnect all of the pieces of the highway. Having this 6.5 miles open again is a major step in that direction. There were many agencies involved with the design and construction of the Hood River to Mosier project. Instrumental in acquiring the property was the Columbia River Gorge National Scenic Area, the Forest Service. The Oregon Department of Transportation designed most of the projects because the funding for the projects came through the federal transportation appropriations. Oregon Parks and Recreation Department will manage the recreational use of the trail. The Hood River to Mosier project is very much a partnership, and I believe it's been very successful. And most recently, the highway has been named as a National Historic Landmark. The Historic Landmark designation means that it's one of the best of the sites that are on the National Register of Historic Places. Less than 3% of the sites on the register become National Historic Landmarks. And in fact, the highway has been determined to be the first scenic highway in the country.
In 1919, the Columbia River Highway opened the gorge to a generation anxious to explore the riches of this magnificent creation. And it's good to know that we too can explore some of the same things that thrilled those who came before us.